Hey everybody, and welcome back to my PortSwigger Web Academy series. If you haven't heard about them, PortSwigger is the creator of Burp Suite, a free security testing tool that researchers, testers, cybersecurity professionals, and companies alike use to assess their security of their web applications. PortSwigger released their Web Academy back in like 2019 or so, and now noobs and pros alike can pretty much try their hand at exploiting OWASP's top 10 vulnerabilities, business logic, API problems or vulnerabilities, and much more while familiarizing themselves with PortSwigger's Burp tool. So, quick disclaimer here, this is not a paid advertisement, nor am I sponsored in any capacity. I'm not getting paid to do this. I'm just a cybersecurity professional looking to help others gain competency while just learning. Really, and using the tool and getting better at their craft. So we're currently building on directory traversal in this playlist, but I have a couple of others that I'm working through. So if you ever get stuck with this Web Academy, feel free to just reference those. I give explanations and walk through the solution. So hopefully it will give you the clarity that you need. And if not, feel free to drop a comment in the box below asking questions, and I'll do my best to answer. So without further ado, let's jump to it. Hey, welcome back. Last directory traversal path lab. I don't know why it was so hard for me to remember lab, but it's the last lab, and it really wasn't difficult. And I'm pretty sure if you came here, it's probably not because it was difficult. Probably coming here for understanding, and I appreciate that you did, because I'm gonna try to explain it to you. You already know what you need to have geared up: Burp Suite, the internal browser, so we can proxy it. Let's get it. I actually did solve this lab already because it was that easy, and I had to refresh, and I was like, oh, it's that easy again. But yeah, let's just dive into it. The solution starts off the same as previous labs. Go to the product page. First, let's read it. The application validates that the supplied file name ends with the expected file extension. And if you don't understand what that means, let's go back to the lab material. I already got it linked up for you. So it's about right here. So if an application requires that the user supplied file name must end with an expected file extension, such as .png, then it might be possible to use a Null Byte to effectively terminate the file path before the required extension, for example. And then it literally gives you the answer. That's why it wasn't that hard. The answer's right there. You just have to kind of change it a little bit. So basically click here. I already have it open. And again, I already solved the lab, but let's just run through it again. Pick any image, who cares which one it is. Go here, and like we've been doing the entire time, you check the file name parameter for what must be changed, and this is where I'm pretty much going to stop here and create the explanation, because excuse me, before I even go further, you see that it first of all, if you did PNG, that's not what we're looking here for. We're looking for JPG. So you basically want to collect what we did last time. From here, you just want to literally copy this and change it to .jpg. So I'm going to stop right there, even though I press enter. And you already know what this means if you've been watching my videos for a while, but I'm going to stop there and provide some explanation here. So we got some explaining to do. And there's a significant difference here that wasn't like any other video we've done. Pre-lab gave us some information about the file extension at the end of the file path when the request gets sent back to the server. Basically, that the server's expecting a certain file extension. When the request gets sent back to it, that means in our attack, we have to use the traversal with an obvious file extension to the end of that. And for anybody who just didn't see the obvious problem, just gonna break it down. You basically have an OS command that must be read as such. But the application only accepts file paths with a file extension at the end of it. And the question is, how can you achieve both and still be able to run the command, the OS command? And that's when you have to inject a null byte. Now, let's just sit and think about, because I'm pretty sure everybody was just like, if you've never heard of a null byte, you probably was just like, what the fuck is that? What is a null byte? How is it going to help us? You're probably Googling your mind off, and I don't know how Google fared out. So in case Google didn't fare out and you came here, let's explain this, because Web Academy didn't, and Google probably failed you. So a null byte is a byte with the value 0. And you can pretty much find this in hex code, for example. It's primarily found in C and C++, and it's treated as a way for an application to stop processing a string immediately. So like everything after this will be ignored. Other languages such as Java or PHP, they don't have a string terminator. At least I'm not aware of a string terminator that they have. If I'm wrong, somebody correct me in the comments, but from my understanding, there's no string terminator. They just store the length of every string separately. And most modern programs and applications are usually written in Java, ASP, Perl for some odd reason, PHP for some odd reason still, or whatever, maybe even Python. So when a null byte is processed by one of these applications, it's just seen as nothing special, and it just basically continues processing and storing the length of the string. So it sees this and it just sees a string. It doesn't see anything special. So that means when we add the null byte via the encoding, like if you've seen in our URL encoding video, it's seen like %, so %00. So that's we're just encoding it. The application that's not written in C or C++ will just process it as a normal string. But wait, there's more. So we replace the file path and add the traversal string, put the null byte at the end, and then we add the expected extension to for the application to just read it as such. So if it's expecting, the application is expecting a string, and then at the end of that string, it's expecting the extension. That's what we want to get it. And that's how it's going to be read. However, under every great application is a vulnerable C or C++ library that's probably being used by said application and ready to process some bull. So our main application will process the command with the attached extension as a normal string, while the underlining C or C++ function being utilized by that main application, more than likely a library of some sort, it will then process that null byte. And when it does, remember, C or C++, whatever, it will see that null byte and it will say bump that point, that .png or .jpeg, because it treats the null byte as a string terminator. So it'll run everything before that and just drop that .jpeg part or that JPG part. So once it sees that string, it's gonna be like, bam, extension dropped, our OS command is ran, And we now have ourselves an Etsy password file in our response, y'all. Let's go up and see it. Whoop, whoop, whoop. That's our response right here to our request. Boom. And our response. So obviously you knew how to solve the lab. It was easy. It was so easy. It was literally easy. But the explanation for some people probably just escaped them. So I hope that brought some clarity to how this attack works, why it works. And yeah, we made it through the directory traversal lab. So keep pushing through these labs, and I'll see you in the next series.